welcome to this
Thanks,
universe.
thanks for having me.
Well, Chris Bensen, Cloud Experience Developer, welcome.
Thank you. Thanks for having me.
All right. So, Chris, I know you've been getting, you're a celebrity actually, both you and the products you design.
I
In
don't know
terms of
about that, but
in terms of I mean, of all the cool demos you create, but especially the supercomputer, Super Pi, Raspberry Pi. So I just thought it'd be kind of interesting just to kind of get a little story behind it. So how did you even come up with the idea of building a supercomputer, first of all?
this started out at Code 1. Which year was that? That'd be 2018.
Okay.
Toward the end of it, Gerald Wenzel came up to me along with Stephen Chen, and there was a Raspberry Pi project. Gerald goes into the details on his one of his blog posts, and he wanted to do a really big Raspberry Pi cluster. He thought it'd be really cool of 1,000 Raspberry Pi, and at the time, I mean, I knew that would be it was an instant good idea. I can't always come up with the great ideas, so I always give credit where credit's due. And but I wanted to kind of, tease him a little bit, and I told him that was a stupid number. And he goes, he's very excitable. He couldn't believe it that I said that was a stupid number. And so finally I said, after egging him on for a little bit, I said, no, you need 1,024 Raspberry Pi. So that was how that kind of started. Okay. So that was October 2018, I guess. And so, after Code 1, we started researching it and seeing what it would take, how much it would cost, get approval, get budget for it and all that. It was about a year ago that the Raspberry Pi boxes showed up. We ordered 1,200 Raspberry Pi. Actually, it was a little bit over 1,200 Raspberry Pi, because the intention was to build some portable versions as well. That the Raspberry Pi Mini supercomputer, and Jasper Potts, and just about anybody that I could bounce ideas off of, because nobody's done anything that big. The Guinness Book of World Records is currently 700. So this is about 50% more, which is considerable.
That's the one that's in Berkeley Labs, is it? Lawrence Livermore or someplace? I think because I remember when I was researching it, I remember reading about it.
Yeah, I remember reading about it. I can't remember where it's located. But yeah, so it's just not, you have that many devices. You start to have to do, professional networks. You can't just use your standard home network with the IP address range of 192.168.
Okay. So can I just pause there? I mean, I know you kind of seems like you pretty much right on the outside decided on Raspberry Pi. And while I was researching supercomputers, and I just thought it's a fascinating field. So obviously on the low end, you've got the Arduino. On the high end, you've got these real, quote unquote, real supercomputers that use Intel's Xeon processors. So just kind of share, like, I don't know, just compare and contrast just at a...
So Arduino. So Arduino are, they're embedded microcontrollers. So you typically need to program them with a lower level programming language, C or C++. Depending on, I mean, you can go lower level, where they don't have all the controllers and stuff, all the electronics embedded for programming it. Arduino is a great platform because it has the IDE, the programming language, everything you need just to have a board, plug it in and go. Great for prototyping. But they're not running a real-time operating system. They're, something like Linux or anything like that. They're embedded running one program. That's it. Just a loop, run your code. So if you just depending on what you're trying to do, if you're running a sprinkler timer or something like that, that can be really, really good for that. I use a lot of those in projects, but something like the Raspberry Pi supercomputer, it's not good for running generic code. You want a computer for that. So in comes something like a Raspberry Pi ARM processor, same processor that's basically in most of your phones. And then there's, of course, Xeons and AMD and all that kind of stuff. And they, have hundreds of cores. And then there's graphics processors. Those are, a whole nother thing that have GPUs. Yeah, those have thousands of cores, but they're very good at doing just one instruction. Whereas as an ARM or an x86 processor like Intel's processor is good for doing just generic processing. The nice thing about Raspberry Pi, what's that?
So just a quick question. So basically, what I understood, and correct me if I'm wrong, so like Arduino starts off like it's like a 8-bit microcontroller. The ARM is like 32, 64-bit. I don't know what mode you use it in. And then once you get to Xeon, I think it gets to like what, 128-bit? Is that kind of the progression?
64, 128, yeah, okay, in that range. The Arduinos, yeah, they're generally 8-bit, sometimes 16-bit, depending on which one you get. And the ARM processors, yeah, the Raspberry is 32-bit. You can get I think you can get a version. I've never tried. I think they're coming out with a version that's 64-bit. Oracle Linux is 64-bit, so it's actually a little bit faster at some things than Raspbian. That was something we encountered.
All right. So talk us through, like, so I think you touched upon some other things. So when you're figuring out the architecture of this, there's a two-part question. One is, how does the hardware-software divide look like? And the other part of it is like, I mean, what goes on in the mind of Chris Bensen when you're looking at all of these variables, performance, size, power? I mean, there's just so much going on. So give us a peek into the mind of Chris Bensen.
There is a lot. And plus, we're trying to provide, a compelling experience, get buy-off for building something like this. So, make it compelling for developers to see it, and make it portable so it can travel. And traveling around the world is a whole nother bag of worms. So first and foremost, we said, okay, we want a 1024 Raspberry Pi. How can, how's this going to kind of look? And then what's going to be a compelling thing to put it in? So after a lot of brainstorming, at first we thought about doing it modular, and that just meant that we were going to have multiple servers, and then those were going to have to communicate over some sort of software thing. And it just added too much complexity to it. So we said, okay, after a lot of brainstorming, going to have to be in one box. How small can we make that box?
Is that why you came up with the idea of putting it in a phone booth?
Well, yeah, you want it bigger on the inside, right? So, yeah, no, we thought about different things that are kind of iconic and stuff, and a blue police box was kind of one of the natural draws. It's also, kind of fitting that the product is made in the UK. So I liked, you try to have these, these tie-ins if you can. And then the other idea was to have it searching for aliens. It's kind of fitting. We ended up doing the aliens on the Mini Pi, but we didn't do it on the
By the way, your backdrop is very befitting of that also.
Oh yeah, perfect. We need an alien, just a flying saucer to come in. So yeah, we thought about, how can we make this portable? That was kind of one angle. There's a lot of these angles, and then they kind of merged in the middle. And after, like I said, months and months of brainstorming this and a little bit of trial and error. So we did the numbers about, how can we get this to travel and be in one box? That's about a pallet. So you could put 2 racks on either side of a 4-foot by 4-foot pallet. they're 6-foot racks. And so then we said, well, okay, let's see how many we can fit in there. Maybe we couldn't fit a 1024. So then there was just a little bit of math with some spreadsheets and stuff to try and find, find the products out there and find ones that were available that we could purchase. 48 port hubs is what we ended up settling on. We tried for larger. We thought about doing power over Ethernet. That had its own problems. The power over Ethernet board that was available at the time was just not going to work. There's going to be it just wasn't going to work. So we said, okay, well, we need the networking. How can we lay this out? So we started talking about how to lay it out, how to power it. That was, like I said, the power over Ethernet. That was a big thing. There was a lot of thoughts there. One of the goals kind of crept up is we're like, well, let's just try and use over-the-counter parts, because one of the things that we did, there was the camera rig with the 62 cameras that did the matrix style 360 camera. Bullet time, yeah. And that we powered that over, used AC power over a lighting, like a track lighting rig, and that has some of its, it was an interesting idea. It had some of its own problems, and from that I was like, well, let's just use USB cables. Let's try and find a giant hub, that can power it, 5-volt hub. So after a lot of research, we found these 60 port hubs. So things just kind of came together after kind of trying to find all the different options that were available, brainstorming it. Even if we had kind of settled on something, Jasper and I would go back and forth all, many hours. He was my big sounding board on this. And
so besides of like off-the-shelf parts, I remember you talking at the Oracle Open World about 3D printed parts. You want to talk a little bit about that? So off the shelf, and
there's a few products out there that are set up for doing Raspberry Pi clusters, and they're pretty turnkey, but they didn't have the density that we needed. So we oriented the Pis a lot of different ways to try and figure out how we could get them in a 1U or a 2U. And we kind of came on this thing, well, okay, networking on the front. And once we turned them, we thought, well, I think we can line up like about 18 of them. and if we print little things. So I went through a bunch of different revisions. If you look at my blog, chrisbenson.blogspot.com, you can see some of those revisions. There was a lot more of those behind the scenes. And eventually fell upon the current model, which has a piece of aluminum, extruded aluminum, cut it down to the right length, and then 3D printed little boards for holding 21 Pi, and it just fits.
Wow.
And so all the networking's on the front, all the power's on the back. And once I found that you could get a 90-degree USB power plug, power cable, then that just worked. So all these things just kind of just fit. And so if you look at the Pi cluster, you'll see that the network switches are just mounted normal with 1-foot cables just curled up, and on the back, that's why all the USB hubs are on the inside with all the power. So it's just something. It's an iterative process. It's brainstorming, researching the products that are out there, not discounting anything, bouncing it off lots of people. Lots of people have different ideas. It's sometimes someone comes up with an idea that you'd already researched, but you didn't exactly write down why you already threw it out, but they have a slightly different twist on it. So maybe it's good. So sometimes you research the same thing, unless you're super organized and have a notebook and picture, a photographic memory and go find that exact page. Some of these things you kind of iterate on and do a couple times. That didn't happen too often, but we once in a while we get, oh, well, that's a different twist on it. Let's research that one. eventually, you just have to build it. And so
Okay. So,
you just sit down and spend 20 hours a day, 7 days a week building the thing.
so how long did it take to build it?
We got, this whole process, we had to order all the parts. They all had to come in. They all came in right around July, I want to say. We had, what I'd realized
July
too
of
that
2019.
July of 2019, yeah. And I realized that we didn't have a place to build it. So, because this thing's going to be monstrous, and we realized that the power requirements was going to be more than what your average home has.
So you couldn't do it in your garage.
I couldn't build it in the garage. I couldn't even really. Well, I did a lot of the prototyping in the garage. So I did the initial printing and the building, and farmed it out to other people that had 3D printers on the team and stuff. And then got everything together. Got the approval for the lab in our Santa Clara office, and had to build out the lab as well. So we built out. The lab came. It took a little bit to get the lab. We got the lab late July. So there was, some of July, August, and September. That was the actual building. And there's, a lot of people. You came in and helped do some stuff. There's a lot of people from our close team. There was some students that came. There were other friends that said, hey, I want to be involved in this. When do you ever get to build something crazy like this? So I had a bunch of friends that had come. So it was a big effort. If you look at see the video it's going up on Pi Day, there's probably about 50 people or so that helped build it. And there's lots of little fiddly things, because you got to put these threaded inserts in the pieces of plastic and put the Pi on and screw it in and then build the things up. So,
okay. Well, I appreciate you giving credit to all the people who participated. So now that it's done, how does it work in terms of working with the Guinness Book of Records?
That remains to be seen. Yeah. So we need to get, there's a whole process there of getting a network expert out and getting approval from management to pay the Guinness Book, because it's not free.
Oh, okay.
And I don't even know what entirely the test is that they want to run on it to make sure that it works, but there's some sort of test that they need to do. So so far haven't had any time, but it's high on my priority list, because who else can say they did something for the Guinness Book of World Records?
And what kind of application have you, or could you run on this supercomputer?
So what we've been running on it, we've been on the servers running Oracle Linux 7.7. So at the time it was the latest version. And each Raspberry Pi is network booting. So there's no SD cards in the whole entire Pi cluster, because 1,000 SD cards, if it took you 1 minute, that would be almost a day if you had like 6 people working on it to plug each one in. So there's just not enough time to actually do that, if you could even reach all of them. So, and you'd have to flash all of them, and it's just
so you have a separate server. You have a separate server in the box that does all that.
So there's a server in the box that boots and it provides DHCP. So it provides static it's a static IP address, but there's a bug in the Pi where it's a dynamic IP address, but we have to provide static IP addresses for each MAC address, because there's a bug in the Pi where it doesn't do the handshake with DHCP properly. Okay. So we have to essentially hard code that IP address to that MAC address. But once you figure all that out, it boots up just fine. Because of Oracle Linux, we did test with other operating systems initially, because we didn't have Oracle Linux set up from the get-go. But once we got Oracle Linux, we were able to boot. It was substantially faster. One, because of 64-bit. And 2, there were some other bugs and other optimizations that we were able to do and get around. So it booted up about 4 times faster and reliably. So it didn't always boot up reliably with other operating systems. So we're running Oracle Linux, and then because we were also running overlay file system, so it's an in-memory file system because we didn't want to have write backs to the server. There's a lot of different ways of setting this up with NFS mounts when you boot the operating system on the Pi, and we wanted one NFS mount rather than one per Pi, and we didn't want to have to do write backs over the network. So each Pi is just a complete dumb device. We don't care if it shuts down or anything. We don't care about the state. So when it plugs back in, it can boot right back up. And because of that, we used overlay file system, which is an in-memory file system. But the side effect of that is you can't run anything like Docker or Kubernetes. Well, then you can't run Kubernetes. So we reached out to the Java community, to Gluon, and they built a community supported software. So it's all written in Java, what we were running at Open World. We had a big TV wall that was a 12K video wall that had a whole nother computer associated with that, but to drive such a large high resolution video wall. But yeah, so there's Oracle Linux.
Video wall is one application. What I know, like in Open World London on the Mini Pi, you were searching for aliens. What other kind of applications you could run on this?
You can run anything. Yeah. So the Mini Pi, we got rid of overlay file system. We did some tweaks to the log files and stuff, so the write backs are happening differently. And so now it's set up so we could do Docker and Kubernetes. So that'll be the next stage. But what we did is for the mini computer, there was a monitor as well, and we were searching for aliens on that Mini Pi using the SETI at Home project, which just closed. So we'll have to find a new project. But there's now that we have Docker, it's open-ended of what we could do. And the Mini Pi was running the latest version of Oracle Linux. I think it's 8.1. So that was a big performance advantage as well.
Right. So changing channels, but relating to this, I'm an avid tennis fan, so I always follow like Roger Federer and see how many Grand Slams he's won. And it's interesting that no matter how big a record someone accomplishes, or Usain Bolt on the field and track, there'll be somebody else who'll come along and break that record. So I'm just quite curious from a technology standpoint. I mean, obviously 1024 is a huge shift from the 750. Is there some kind of like law that would limit how much you could scale this, like Moore's law, processing power, or Metcalfe's law regarding networking, or could this scale infinitely?
There's always limits, and then there's always ways of getting around those limits. So building an actual supercomputer with Raspberry Pi, there's other ways of accomplishing the same or more processing power in the same amount of space with the same amount of heat and all that kind of stuff. The Raspberry Pi lends itself, since we have 4,096 processors and 1,024 gigs of RAM. I can let those numbers sink in. It's really good for things like simulations. So a lot of people comment, oh, well, you could just have a graphics processor, and a GPU and have more processing power. Yeah, but that's one thing. This could run, let's say, an ant colony where each ant has a little slice of a CPU. So, could you take that and grow it? It wouldn't be portable. The Raspberry Pi 4 is compelling. They're a lot faster than Raspberry Pi 3B Plus that we used in our project. The heat and power consumption would have been higher. We actually disabled the USB and the Bluetooth and the Wi-Fi to get the amount of power down to about 1.2 amps versus it's about 2.5 is 2.4 is what a Pi normally pulls in, and it you know, so I mean, that'd be the obvious choice. It would be to upgrade it to Raspberry Pi 4, but you know, and I'm not worried about someone coming in and making a bigger one. In fact, I hope someone does. I think that would be cool. But like I said, there's no way it would be portable. I'd love to see it if they could put it in as small of a package. I would, call me up, please. As far as other things, you know, growth, like how many you could go, you know, like I said, there's just engineering challenges with networking and stuff. You'd have to have servers running slave units and you know, partition it off into sub clusters or something like that. But it would be possible, yeah, for sure.
All right. Well, Chris, it's a fascinating project. I want to congratulate you on having a mission accomplished.
Thank you.
Yeah, just keep on coming out with those cool demos, and look forward to talking to you another time, another place.
I will. Thank you. Thank you, Javed.
Thank you.
Thanks for having me.